So here we are at 13.2, finding outcomes, and we are going to start with how to keep track of our outcomes and finding them using a tree diagram. You will be asked to do these techniques on a quiz test or whatever, so even if you say, oh, I already know what the outcomes will be, I can just list them, you need to show it on a tree. So let me show you what that looks like. So let's say that you are going to be able to go to one of those places where you can paint an item, and you get to choose either a small or a large vase, jar, or plate to paint how you would like to. To use a tree diagram to do this, there are two choices, small and large, and in each choice you have a vase, jar, plate, and in a large you have a vase, jar, plate. So what I did was I did abbreviate: small vase, small jar, small plate, large vase, large jar, large plate. Okay, so when you do this, you want to be able to come to the end and be able to list your 6 possibilities for what that is. So this is kind of a sideways tree. I have had students in the past say, well, a tree goes like this or grows like this. Can I do it like that? That's fine with me, but the reason it's a tree diagram is because it branches off. It really doesn't matter what direction. So this is a really quick one too. A hockey team needs to choose jerseys. The choices of the main body color are red, white, purple, green, and blue, and then you can have a different sleeve color, and those choices are black, red, and blue. So we need to draw a tree diagram. What I like to do is I like to start with the one that only has the 3. So I'm going to do black, and let's do this one up and down. I'll show you that it works the same. Black, red, and blue. It's weird to write these colors in a different color. And then for black, we have red, white, purple, I'm just going to abbreviate, green. So even though we have a red body color, you still could have red sleeves, white, purple, and green. And then blue, red, white, purple, and green. So this is going to show you have 4, 8, 12 possibilities. You would then, the final step is to do black body color with red, black body with white, black body with purple, and then black body with green. So you would do that all the way down for all of these. So while it isn't hard, it is a little bit cumbersome and it takes some time. Please do keep in mind that you will be expected to do the tree diagrams with your assignment and quiz test. So now the last thing I need to talk to you about in terms of how outcomes is some things are a combination type of an outcome. It doesn't matter what order that things are in. And another thing is a permutation. And that it does matter what order things are in. So a combination is a grouping of objects where order is not important. So like ice cream toppings. If you want chocolate and caramel, it doesn't matter whether I say chocolate and caramel or caramel and chocolate. That either way would be fine. You're saying the same thing. Where permutation, order is important. So it could be a safe combination, usually having to do with numbers. I think of permutations generally having to do with numbers. Or the order that students can go into a play or something like that, where order does matter because you won't be first. It doesn't matter who gets to be first, that sort of thing. That is where the order does matter. So we're going to go through the ice cream shop one together since it was in our little example there. And what I'm going to do is I made a chart, and I want to show you this chart because it is super important that you are able to organize the information. And I know some of you will have a little bit of trouble with this. So you get to choose only 2 toppings in this particular ice cream shop. I don't know about you, I wouldn't go there because I would want more than that, but you only get 2 toppings from the list. And so let's look at all of the possible outcomes if your choices are nuts, sprinkles, caramels, and marshmallows. And let's assume that those of you with nut allergies don't have them just for the sake of this. So we're going to start with nuts. You can have nuts with sprinkles, nuts with caramel, nuts with marshmallows. Okay. Now, if I go to sprinkles, remember I've already done nuts with sprinkles, so I'm not going to go back and do that one, but I could have sprinkles with caramel, or I could have sprinkles with marshmallow over here. And then when I go here, we've already had caramel, or we've already had caramel with sprinkles, and we've already had caramel with nuts. And so all we need now is caramel with chocolate, or marshmallow, I mean, right here. So if you start right here and you do all the possibilities, then this one you only have these, and this one you only have the one to the right. So you would write the outcomes. So this would be NS, and then NC, NM, and then SC, and then SM, and finally CM. So when you have 1, 2, 3, 4 topping, the possible combinations are 1, 2, 3, 4, 5, 6. I want to point out to you, it doesn't matter whether you order marshmallow and caramel or caramel and marshmallow. It's all going on your ice cream. So that's a combination example. A permutation would read something like this. List all of the 2-digit numbers that can be found using 2 different digits from 1, 4, 7, and 9. So this one, it does matter what order the numbers go in. So let's say that a number starts with 1. Let's find all of the possibilities if your digit starts with 1. So I see that it would be 14, 17, and 19. All right, now let's go to the 4. What are the possibilities if your 2-digit number starts with a 4? Well, we would go back to the 1 and notice it's the flip of 14, but 41 is a different number. So order does matter here. And then it would be 47. You can't use the numbers twice, by the way. All right, now let's start with the 7. So that would be 71, 74, 79, and then the 9. 91, 94, 97. So we would have 3, 6, 9, 12 permutations using these 4 numbers. Notice we had 4 up here too, but we only came up with 6 because the flip of them didn't matter. So we would have had 12 if the order mattered. Down here, we also had 4 possibilities, but the flip of them did matter. The order of them did matter, so it came out with double the outcomes. It's so important that you read what they're looking for to see whether the combination or the permutation is what you're looking for. The tree diagram sometimes gets kids encumbered with writing. So what I want to show you is one of the reasons that we do it is it's easy to forget what happens with coin flips and things like that. So let's say we're going to flip a coin 3 different times. So for the entire event. So we're going to have 3 coin flips, and I'm going to do 1, 2, 3 flips. Okay, so in the first one, I'm going to have this be my point. Let's say that you get a head on the first event and then a tails on the second event. Well then, or on the first event. On the second event, you could either do a heads or you could do a tails. And down here, you could do a heads or you can do a tails. Now this is why it's really, really important, because now this third event increases the possibilities to a point where you're not going to remember all the combinations. So here we have heads or tails. Here we have heads or tails, depending on how it goes. Here we have heads or tails. And here we have heads or tails. So let's list all of the possible outcomes. And I shall do that in purple because it makes me happy. So we could have done heads, heads, heads. That's one of them. I could have done heads, heads, tails. I could have done heads, tails, heads. Heads, tails, heads. Or I could have gone all the way down and gone heads, tails, tails. All right. Now let's look at the bottom where we did tails on the first flip. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. Tails, tails, tails. So when we do this, we have 1, 2, 3, 4, 5, 6, 7, 8 possible combinations. So there's 8. So what are the chances that you would flip 3 heads in a row? I would say, well, it's 1 out of 8 chances. But what if we said, what are the chances that you have at least 1 head in your flip? So the only one that doesn't have at least 1 head is this one. So you have a 7/8 probability of having a head in your flip. You also have a 7/8 possibility of having a tail in your flip. So you see why it's important to be able to know all of the possibilities. And I would guess that if you just did this in your head, a lot of times kids leave out one of these combinations of the heads, tails, heads ones. That's why tree diagrams are important. A lot of times you're going to see just 2 in your assignment, but once you get to that 3rd and the 4th event in your set of, or 3rd or 4th thing in the entire event, it makes the combinations a little bit more interesting, if you will, or complicated. Please see me if you have any questions. It's not a tough assignment, but it will make you think, and it will take some paper. Please kill a tree today, everyone.